Human vision is not much help in studying distant worlds. That is why inventors on Earth have been creating spyglasses and telescopes for centuries, whose eyepieces, defying vast distances, have helped us peer into the depths of the universe. Over time, scientific progress made it possible to send spacecraft equipped with cameras to the surfaces of the planets in the solar system. Thanks to them, we were able to see with our own eyes mysterious craters, unexplored valleys, rugged cliffs, and other details of alien landscapes. Mars is the favorite when it comes to exploration. It has received more visitors from Earth than any other planet. So what did they see on this barren and gloomy yet so alluring planet? Here is a unique collage of Martian images taken from the catalogs of various missions that have ever visited this rocky celestial body. Subscribe. In this image, you can see an outcrop with thinly layered rocks in the Murray Buttes area on Mount Sharp. In this image, you can see thinly layered rocks in the same location. Here you can see a slope in the Murray Buttes area on Mount Sharp. In this image, you can see slanted edges and a multi-layered outcrop in the Murray Buttes area. And here is a map showing the route taken by the rover from the place where it landed in August 2012 to the location where the rover was in early March 2016. Did you know that the sand on Mars is special, completely different from the sand on Earth? The proof of this is the relief-textured sandstone on Mount Sharp. These are pieces of Martian soil visible in the lower left and upper parts of the image. You can also look at it under a microscope, just like the Phoenix probe once did. Here is a close-up of Martian sand grains. At night, NASA used electric lamps to better illuminate the regolith particles. The leeward side of a sand dune on MIP, doesn't it look just like Africa? Marias Pass, the contact zone of two Martian rock formations photographed on May 22, 2015. Now let's take a look at the side of Mount Bagnold. This image, taken from Mars orbit, shows a sand dune. It's the first one the rover will visit. The animation shows the movement of the dunes, recorded in 2010 and 2014. And here is Garden City in the vicinity of Mount Sharp. The probe's camera demonstrated a network of mineral veins beneath the ridge of bedrock on Mount Sharp, March 27, 2015. The next image shows dark material with different chemical compositions found in the mineral veins of Garden City. Take a closer look. In front of you is a dark, thin material filling the cracks in the ground. This is a set of images with overlaid histograms using the chemistry and camera ChemCam tool. As you can see in this image, the mineral veins in the Garden City area vary in thickness and brightness. Here, a geological contact is recorded where pale rock meets a darker overlying hill. The image was taken on May 21, 2015. What could be more beautiful than a sunset in a Martian crater? Probably only one on Earth. The rover recorded this sequence of images of the setting sun at sunset on the 956 Sol. This map shows the route across Mount Sharp. The green star marks the rover's location after the drive on April 16, 2015. The map covers an area about 2 kilometers wide. And now, let's watch the robots at work. The rover's environmental monitoring station includes temperature and humidity sensors mounted on the rover's mast. This image is a close-up of a 2-tone mineral vein at a location called Garden City on Mount Sharp. And where is the rover? Has it gotten lost? The rover can be seen in this image in the Pahrump Hills area of Gale Crater. In this photograph, taken on January 13, 2015, the results of a mini drill test needed to assess the Mojave Rock are shown. Now the rover knows whether it can drill to full depth to collect samples. This graph shows a comparison between the amount of an organic chemical called chlorobenzene found in the Cumberland rock sample and its amount in fragments of 3 other types of phosphorus. You will visit the bottom of an ancient body of water. Signs of the channel of a dead Martian lake show a typical pattern of sedimentary bottom deposits, not far from where water entered the body of water. This series of images reconstructs the geology of the region around Mount Sharp, where the rover landed. The images have been altered to illustrate how deposits can accumulate during alternating dry and wet periods. The image shows an example of a thinly layered, evenly stratified type of rock found in the Pahrump Hills outcrop at the base of Mount Sharp. This type of rock can form beneath a lake surface. Diamond-shaped crystals are visible in this magnified image of the Martian rock called Mojave. These features record the concentration of dissolved salts, presumably at a high level. This image shows an example of crossbedding, which occurs as water passes through a loose layer of sediment. In the foreground, several layers of sandstone show a systematic southward dip, indicating the gradual buildup of deltaic deposits in that direction. And now let's turn our gaze to the sky. The rover observes comet sighting spring passing near the red planet on October 19, 2014. This image shows distinct bands of alternating brightness within the Murray Formation on Mars. Such bands are quite common, although their origin is unknown. The image shows a mesa in the Murray Buttes region. And the last image, a pit in the Martian soil during repeated laser shots from the Mars rover. This slow-motion 16-frame film shows how repeated laser shots lead to the formation of a pit in the Martian soil. The area of soil included in the image is about 28 millimeters across. By looking through all the provided images, a person who has never visited Mars can get a rough idea of what landscapes await the colonists who dare to settle on the red planet. Not a very hospitable landscape, is it? And the weather isn't pleasant either. There's only one consolation. Perhaps after thousands of years, we will be able to terraform our dusty neighbor, turning it into a clone of Earth. So, until that happens, hurry up and enjoy the authentic Martian. Human vision is not much help in exploring distant worlds. That is why inventors on Earth have spent centuries creating spyglasses and telescopes, whose eyepieces defying vast distances helped us peer into the depths of the universe. Over time, scientific progress made it possible to send spacecraft equipped with cameras to the surfaces of planets in the solar system. Thanks to them, we were able to see with our own eyes mysterious craters, unexplored valleys, rugged cliffs, and other details of alien landscapes. Mars is the favorite when it comes to research, It has received more visitors from Earth than any other planet. So what did they see on this barren and gloomy yet so alluring planet? Before you is a unique collage of Martian images taken from the catalogs of various missions that have ever visited this rocky celestial body. Let's start with the Titanic structures. This image was assembled from dozens of pictures taken by the masked Curiosity camera. It was taken on the 1931st Sol in January 2018. Mount Sharp stands in the center of Gale Crater, which has a diameter of 96 miles. Would you like to take a closer look at Mars on a microscopic scale? Yes, please. This photo shows Martian thin-layered rock, which includes tiny crystal-shaped bumps, as well as mineral veins with bright and dark material. And in this case, it shows how to highlight the feature of interest using the standard tools provided by the probe's scientific instruments. The image demonstrates how using special filters available on the mass camera of the Curiosity Mars rover helps to detect the presence of certain minerals in target rocks. The image is a combination of photographs taken through 3 filters, chosen so that hematite, an iron oxide mineral, stands out as an exaggerated purple. Here is the Curiosity rover at work, conducting testing on October 17, 2017, as the team developed a new way to use the rover's drill. This image shows the drill touching the ground during measurement assessment by the sensor on the robot's arm. In this image of Vera Rubin Ridge taken by the rover's chemistry and camera instrument, you can see sedimentary layers, mineral veins, and the effects of wind erosion. Martian landscapes are an inexhaustible subject for cameras on probes sent from Earth. Here, for example, is a view of Vera Rubin Ridge from below, Sol 1734. This place was designated for the Curiosity rover even before the spacecraft landed in 2012. And here's another view of Vera Rubin Ridge on Mount Sharp on Mars. The structure is located right above the reddish rocks of the Murray Formation. This image shows a dark hill called Irizon Hill, which rises about 16 feet above the layered exposed red materials covering the slopes of Mount Sharp. Here is a map showing the route taken by the Curiosity rover from the location where it landed in August 2012 to its position in July 2017. Sol 1750 as well as the planned route to additional geological layers of Mount Sharp. Do you think there are no dunes on Mars similar to those on Earth? You're very mistaken. Take a look at the Nathan Bridges dune on a mountain on Mars. It was one of the research stops for the campaign to study active Martian dunes. Nathan Bridges.
566-2017 помог возглавить
this mission. And here's another panorama with an active linear dune in Gale Crater. And here are the textures that the Curiosity rover studied on the Martian dune. This image shows 2 scales of ripples. There are also unique whirlwinds on the red planet. Dust devils dance in a sequence of images taken on February 12, 2017. A dust devil passes near a Martian sand dune. Take a look, a Martian dust devil in Gale Crater.
1597.
This pair of images shows the effects that occurred in a single Martian day. The photo demonstrates sand blowing under the rover's chassis. And this photo takes us back to Mars's ancient past. This network of small polygons on the surface of a Martian rock near the right edge may have formed as a result of cracks in drying mud more than 3 billion years ago. One more thing, another interesting photo. In the foreground, you can see purple-tinted rocks near the rover's location at the end of 2016 on Mount Sharp. Would you like to take a look at the iron-nickel meteorite struck by the rover's laser on October 30, 2016? It is worth noting that the dark, smooth-surfaced rock was meticulously examined using laser pulses, and it was confirmed to be an iron-nickel meteorite. This is a 360-degree panorama from the rover on Mars. This is what our gloomy neighbor looks like. In this self-portrait of the Mars rover, the vehicle is shown at the drilling site of Kila in the Murray Buttes area on Mount Sharp. And in this shot, the moment of truth is captured. The chart shows the locations where the Mars rover collected its first 18 rock and soil samples for analysis by laboratory instruments. They are drilling M9A and Murray Buttes on Mars. The top of the hill in this scene from the mass camera is about 5 meters above the rover and 25 meters southeast of it. Do you want to see pictures from the Farewell to Murray Buttes series? Here they are. In this photo, you can see an outcrop of a hill with layered rocks in the Murray Buttes area on Mount Sharp. SpaceX plans to send the first people on a 6-month journey to Mars. This journey will be just the beginning of Elon Musk's global plan to turn humanity into a multiplanetary species. To achieve its bold goals, SpaceX needs to establish the first base on Mars, and after some time, the first Martian city. But how is that possible? How will the first colonists manage to establish a base on Mars? What rules will they need to follow? What will need to be done to build a self-sustaining city on Mars? When the first volunteers arrive on Mars, they will need to find a suitable place to establish the colony. It is known that the surface of Mars is much more radioactive than Earth's. In addition, the temperature conditions on the surface are also quite different from those on Earth. The average temperature on Mars is approximately minus 40 degrees Celsius, while the average on our planet is plus 14 degrees. The habitat of the first Martians will most likely be built beneath the surface of the red planet. Later on, if circumstances are favorable, more complex structures could be built on the surface. It is planned to cover them with a thin layer of water which should protect against radiation. Nevertheless, delivering a huge amount of materials and water to Mars to build this technological marvel will require enormous financial investments. If the first Martian settlement is destined to turn into large cities, the settlers will need to use materials found on Mars. Fortunately, Mars has plenty of useful resources. The planet's surface contains metals such as iron, magnesium, and aluminum, and electricity can be generated using solar collectors. Oxygen is present in the planet's atmosphere, and ice beneath the surface can provide water. But once Martians start extracting these resources for their own use, who will become the true owner of this wealth? In 1967, the United States, the United Kingdom, and the USSR signed the Outer Space Treaty. According to it, no state can claim ownership of a celestial body or any part of it, and the sovereignty of states applies only to the space objects they have directly launched. Thus, the inhabitants of Mars will be able to manage their own resources and even create their own laws regarding their use. So far, everything looks very promising. However, history teaches us that creating a new colony is always a risk. In May 1607, 104 people landed in Jamestown, the first English settlement on the territory of what is now the United States. By January, only 38 people were still alive. Most died from disease and hunger, while others were killed by hostile Native Americans. Establishing a settlement on another planet will be an even more difficult task, possibly almost impossible. Many scientists are convinced that the time for colonizing other celestial bodies simply hasn't come yet. Astronomer Vladimir Georgievich Surdin believes that it would be much easier and more effective to focus efforts on colonizing and developing the Sahara, Antarctica, or Greenland. There are still areas on Earth that are much easier to develop. Just think of the almost uninhabited Siberia and the basins of the world's oceans. To protect themselves from conflicts over mineral resources, the colonists should establish a shared economy before arriving on Mars. This economy should be based on trading local resources or supporting a new Martian currency. Naturally, for this economic model to function properly, strong local leadership will be required. At the same time, the first settlers have a chance, remembering the mistakes of their predecessors on Earth, to create a much fairer model of organization, to build a society. Elon Musk suggests that the best form of government for Martian colonies would be direct democracy, where everyone can cast their vote to make or reject decisions important for the entire colony. In his opinion, representative democracy, which has existed for a long time in many countries on Earth, is prone to corruption and will not be suitable for young Martian settlements. Another problem is the possible threat of war. The settlers will face a severe shortage of resources if the systems for extracting water and minerals turn out not to work as efficiently as expected. In addition, imagine the mental state of a person who finds himself so far from home. The more colonists arrive, the more they may be divided by language, nationality, and ideology. Without proper control, all these factors can lead to complete chaos, a surge in mental disorders, and unfortunately, war. So far, it's hard to call Mars hospitable, but just imagine the first generation of children born on Mars. For them, the red planet will truly be home. Underground shelters, sandstorms, and radiation will be as familiar to them as city streets, oceans, and snow-covered mountains are to us. For them, Earth will forever remain a foreign world. It's hard to say now whether the endeavor of Elon Musk and all those who dream of taking humanity into space and settling other worlds will be successful. But the idea that such a great dream could help unite humanity seems undeniable. We haven't solved all our problems here on Earth, but maybe by coming together for such a grand goal as the colonization of Mars, we can forget about earthly prejudices. Like this video, if you believe that human cities will one day rise above the Martian lands, write in the comments what other problems the first settlers on Mars might face and what, in your opinion, could help solve these problems. Perhaps millennia will pass, and we will manage to terraform our dusty neighbor, turning it into a clone of Earth. So, until that happens, hurry up and enjoy the authentic Martian landscapes. Actually, you know what? That's already too much information for today. Let's continue the story in the next video. And to make sure it comes out, perform the magical triple ritual. Move the almighty cursor to the thumbs up under this video, subscribe to the channel, and click the bell to turn on notifications for new content. To do this, you need to click this button and hit this bell. Do it, and the universe will definitely reward you. Thanks for watching, and see you soon.